Hello students, welcome back to Future Foundation. Students, in last class of three-dimensional geometry, we started plane and discussed case 1 for the equation of plane, that is when a point through which plane is passing and distance of plane from origin. These two conditions are given, right? Now in today's class, we will discuss case 2 for the equation of plane. So let's start the class. So students, first of all, write down the heading equation of plane passing through a given point and perpendicular to the given vector. So students, this is case 2 for having equation of line. If these two things are given, that is a point through which a plane is passing and a normal vector to which plane is perpendicular. So if these two things we have, then we can find the equation of plane always. Let's say this is the plane and this is the or normal vector, right? And say it is a point having position vector a vector, and this is a general point P having position vector r vector, right? So we can say from figure that AP vector dot n vector is equal to 0 because AP vector is perpendicular to n vector, so dot product is 0. AP vector is nothing but r vector minus a vector dot n vector is equal to 0. Okay, or you can write r vector dot n vector is equal to a vector dot n vector, and a vector dot n vector is a scalar quantity. We can write it as some k as well. So r vector dot n vector is equal to k, right? So this is the equation of plane in vector form. Okay, so it is a vector equation of plane. Now if I am interested in finding the equation in Cartesian form, then we can also write r vector as xi cap plus yj cap plus zk cap, right? And n vector is equal to ai cap plus bj cap plus ck cap. Then r dot n will become ax x y z dot a b c is equal to k, or ax plus by plus cz is equal to k. This is the Cartesian form, okay, or Cartesian equation of a plane, right? So now let us do some questions. Question is, find the equation of plane passing through the point 2, 3, 1 having 5, 3, 2 as the direction ratios in normal to the plane. Right, students? For having equation of plane, we need two things, right? One is point and second thing is normal. If you know the direction ratios of normal, then you can write normal as well. So if direction ratios of normal is given, then n vector can be written as 2 I cap plus 3 j cap. Then if direction ratios of normal are given, then normal can be written directly. So if direction ratios are 5, 3 and 2, then n vector can be written as 5 I cap plus 3 j cap plus 2 k cap. Okay, and e vector is also given, which is 2 I cap plus 3 j cap plus k cap. Okay, so equation of plane will be r dot n, that is 5, 3, 2 is equal to a dot n, that is 2, 3, 1 into 5, 3, 2. So it is nothing but 5x plus 3y plus 2z is equal to 10 plus 9 plus 2, right? So it is nothing but 5x plus 3y plus 2z minus 21 is equal to 0. Okay, now let us see other question. Question is, the foot of the perpendicular drawn from the origin to a plane is 1, 2, minus 3. Find the equation of the plane. See students, foot of perpendicular is given, right? Say this is a plane and foot of perpendicular from origin to the plane is given. Say this is M, which is foot of perpendicular, and it is origin O. Foot of perpendicular is 1, 2, minus 3. So for having equation of plane, we need a point to which plane is passing, and here in this case M is that point which is lying on the plane, and also normal vector is also required, and in that case and in this case normal vector is OM vector. So here n vector can be written as 1 minus 0 I cap, that is I cap plus 2 j cap minus 3 k cap, right? Because n vector is nothing but MO vector, OM vector, and E vector is I cap plus 2 j cap minus 3 k cap. It is same as n vector. So equation of plane in this case is x, y, z, that is r dot n, which is 1, 2, minus 3 is equal to E dot n, 1, 2, minus 3 dot 1, 2, minus 3. Okay, so it is x plus 2y minus 3z is equal to 1 plus 4 plus 9. So it is x plus 2y minus 3z minus 14 is equal to 0. Okay, now let us see one more question. Find the equation of the plane such that image of point 1, 2, 3 in it is minus 1, 0, 1, right? Students, see it is a plane, and what is given to us? Image of point 1, 2, 3. Say this is point P, 1, 2, 3. Its image is Q, which is 1, minus 1, 0, or 1, and 1. So if P and Q are given, here in this case Q is the image of P, so we can have the midpoint of PQ, and which is of course lying on the given plane, right? So here M would be 0, 1, 2. Okay, also normal vector can be PQ vector, and which is Q vector minus P vector, which is minus 2, minus 2, minus 2. Okay, So equation of plane would be r dot n is equal to a dot n, and here a is 0, 1, 2, which is a, right? So x, y, z dot -2, -2, -2 is equal to 0, 1, 2 dot -2, -2, -2, which is -2x -2y -2z is equal to 0, -2, -4. Okay, so x plus y plus z -3 is equal to 0, which is required equation of plane. So students, let's meet in next class. Till then, bye bye, take care.